Good morning, students. Welcome you all to this online lecture series on VLSI design, the subject of your current semester. In the last lecture, we studied applications of VHDL, where we covered part A. Now let's continue with our study in continuation with the previous topic of applications of VHDL. And today we shall discuss part B of this topic, that is various applications of VHDL. So let's continue with this topic. As you see on the next slide, so today in this online lecture of VLSI design, we shall be talking about various topics related to applications of VHDL, like we shall discuss what are code converters, comparators, and Boolean functions. We shall study what are their purpose, why they are used. We take few examples to study their VHDL code, and for better understanding we shall observe their block diagram also. So let's study the first topic, that is code converters. Let's start our discussion. Let's move to the next slide. As you see on the slide, for better understanding of this topic of code converters, we can further explore this topic in various major categories. These are basic definition of code converter, then we study what is purpose of this design, then we study its block diagram, and after that various examples shall be taken up to understand this topic in a better way. Let's explore these four in detail now and start with the topic code converters. Now the first question comes to our mind, what is code converter? The definition says that the code converters are those circuits which are used to convert the information. Now this conversion can be from one format to another format. Take an example of gray to binary code converter, or binary to BCD code converter, or BCD to binary code converter, etc. So these are basically those specific encoders and decoders which convert the data one form to another encoded form. Now what is the purpose of this conversion? These converted codes are used in different circuits for various purposes. What are those purposes? Those purposes are data encoding, data encryption, data security, etc. Let's take an example to understand this topic. As you see on the slide, an example of code converter is shown. This is an example of the gray code to binary code converter. Its block diagram is shown on the right within 4 inputs G0 to G3 and 4 outputs B0 to B3. Now the inputs G0 to G3 are converted to form the 4 outputs B0 to B3. Now let's study its VHDL code. As you see on the left, the VHDL code for this code converter is shown. Initially the library declaration is done, then entity is defined for code converter, that is gray to binary. Then inputs are defined in bit vector form, that is G from 0 to 3 and B from 0 to 3, and then entity is closed. The architecture part covers the basic logic as shown for the final outputs B0, B1, B2 and B3. These inputs G0, G1, G2 and G3 are converted using logical circuits. such as XOR gate to its equivalent binary code, that is B0 to B3. As you see, B3 bit equals G3, B2 equals to XOR of G3 and G2, B1 equals to XOR of G3, G2 and G1, B0 equals to XOR of G3, G2, G1 and G0, and then architecture is closed. This completes the VHDL code of this code converter. I hope you have now understanding of this topic of code converter. Now let's move to the next slide for the study of comparator. As you see on the slide, the block diagram of the code converter is shown. Let's explore this topic starting with a very basic question, that is, what is comparator circuit? The definition says that it is a combinational circuit that is used to compare two digital or binary numbers. And after comparison, this comparator circuit provides the decision, that is, whether one binary number is equal, greater or smaller than the other. The basic purpose of comparator is just to compare the input data bits and provide the desired output. For this comparative decision, it uses standard logic gates like AND, NOR, NOT gates, etc. The practical applications of comparators are 1-bit, 2-bit and 4-bit magnitude comparator circuits. Let's take an example for the better understanding of this topic of comparator circuits. As you see on the slide, an example of comparator is shown. As you see the block diagram on the right, two inputs are there, that is A and B, and the three outputs are there, that is equal, greater and lower. Now these inputs are logically compared together to form the output as per the comparative outputs of A is equal to B, A less than B or A greater than B. Observe its block diagram for better understanding. Now let's study its VHDL code. Initially the library declaration is done, then entity is defined for the comparator called comparator 2-bit. Then inputs and outputs are defined there, that is A and B for inputs and equal, greater and lower for output, and then entity is closed. The architecture part covers the basic logic as shown for the final outputs, that is A is equal to B, A less than B or A greater than B. These inputs A and B are compared to provide the final output. Then architecture is closed. This completes the VHDL code of this comparator. I hope you have now understanding of this topic of comparator. Now let's move to the next slide for the study of Boolean functions. As you see on the slide, we have shown the block diagram of the Boolean function on the right. Let's explore this topic in detail now, starting again with the very basic question, what is a Boolean function? The definition says that a Boolean function is a function which is used in logical arguments. Also, we must keep in mind that the Boolean function always follows Boolean equations. Now what are these Boolean equations? These are based on the concept of logical equations. These functions are based upon the binary concept, that is low and high or 0 and 1. Also, these functions are many times called as switching functions. Now what is the purpose of these Boolean functions? These Boolean functions are used to implement various logical expressions. That may be some gate like AND, OR, NOT, NAND, NOR, XOR, XNOR gates, or the combination of these gates. Let's take an example to understand it better. Let's move to the next slide. As you see on the slide, an example of Boolean function is shown. This is an example of logical circuit to implement y is equal to ACD plus BC plus BD. Observe its block diagram. 4 inputs are there, that is A, B, C and D, and one output is there, that is Y. Now these inputs are logically decoded to form the logical output as per the logical equation y is equal to ACD plus BC plus BD. Now let's study its VHDL code. Again, initially the library declaration is done, then entity is defined for this Boolean function called log fun1. Then inputs and outputs are defined there, that is A, B, C and D for input and Y for output. Then entity is closed. The architecture part covers the basic logic as shown for the final output Y, that is Y is equal to ACD plus BC plus BD. These inputs A, B, C, D are logically connected to form the final logical output Y, that is Y is equal to A and C and D, or of B and C and or of B and D. Then architecture is closed. This completes the VHDL code of this Boolean function. I hope you have now understanding of this topic of Boolean function. In this way, this was all about applications of VHDL, where we covered part B today. In the next lecture, as you see on the next slide, we shall be covering part C of applications of VHDL. We shall be covering various topics like sequential circuits, shift registers and counters in the next class. Thank you.